Hello everyone, welcome to my class. Welcome to my Calculus 3 class. This class also called multivariable calculus class. Let me start the class right away. In today's class, I will cover sections 12.1. So before starting the class, let me give you a short introduction of Calculus 3. In Calculus 3, we generalize the concepts and techniques that we learned for function of single variable to function of several variables. In particular, to function of two variables and function of three variables. In another word, we study the calculus of functions of two variables and three variables. The whole point of Calculus 3 is that the input and output of our functions come from a set larger than R. R is set of reals. So the questions we ask ourselves at this time is how to get a set larger than set of reals. Here R is set of all reals, which we also call a real line, just a real line in the diagram here. Similarly, next R is square, R cross R, that means one is R and then we cross another R, making mutually perpendicular. We define R is square as set of all order pairs, and R is square also called plane or 2D. Similarly, we can find R3 where we cross three R's mutually perpendicular to each other. So this is R, this is R, this is R, and they are mutually perpendicular at this point. So the RQ is defined as set of all order triples, and RQ also called 3D space or just a space. Similarly, we can generalize this idea. We can define Rn, that is R cross dot 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 cross R. That means we have n many R we are crossing here, and Rn is the set of all n tuples. I hope this definition makes sense to you all. Now, quick note, we mainly focus on R2 and R3 cases. They are formed by a point, which is called origin, and a basis consisting of mutually perpendicular vectors which define the coordinate axes, x-axis, y-axis, and z-axis. So first we introduce a three-dimensional Cartesian coordinate systems, and then in next sections we'll define vectors. So let's officially start the Calculus 3, sections 12.1, three-dimensional Cartesian coordinate systems, also denoted by R cubed or R3 or space. Okay. The coordinate of any point P on R3 are determined by order triples of real. The best way to visualize this system is to look at a corner of the room. So then let me go to the diagram to explain the diagram here. So in the diagram, you see this is the x-axis, this is the y-axis, and this is the z-axis. So these three axes intersect at origins, mutually perpendicular to each other. And if you compare this origin is at the corner of the room, then on our right side, this is the yz plane, and our left side, which is a left wall, which is a xz plane, and we are standing or with a floor, this is a xy plane. So these three planes are intersecting mutually perpendicular at here. I hope this makes sense to you. And on this side here, on my left side, so here's R3 is defined as set of all order triples. Xz plane is y equals to 0, yz plane means here, which is x equals to 0, and xy plane, which equation is z equals to 0. I hope this makes sense to you all. And quick note, the coordinate axis divides the space into 8 parts called the octant. So the 4 octant is on the up here and the 4 octant on the down here. So it's 4 rooms here in the maybe second floor, you can think that way, and the 4 rooms in the first floor, just down below these 4 chambers. So I hope this makes sense to you all. And in terms of the coordinates, the first octant can be described as a set of points whose coordinates are all positive. So here's all positive. So here's first octant, all coordinates are positive. Second octant, the x component is negative, others are positive, and so on. So 4 lies up, 4 lies down. I hope this makes sense to you all. So now next, let's talk about plotting the point on R3. So the Cartesian coordinates of a point in the space is written as with 3 coordinate here, P, X, Y, Z. This describes the points east to west, north, south, and up, down displacement of the point from the origin. So that means X positive negative side, Y positive negative side, and Z positive negative side. And the Z coordinate of a point indicates the altitude of the point. That means how far off that point from the ground. This representations of a point is unique. Notice that each point forms a rectangle while finding its positions. So the system is also called rectangular coordinate system. So for example, the point P, whose coordinate are x, y, z, that means this point P is x unit along the x-axis, y unit along the y-axis, and z unit along the z-axis. So then this also forms a rectangle here. For example, let's take x is 1, y is 3, and z is 2. Then this is the point P here. That means 1 unit walk along the x-axis. So from origin, 1 unit along the x-axis, and this y is 3. Then walk 3 units along the y-axis or along the line parallel to y-axis. Then we are here. And then this is z equals to 2. So then walk 2 units along the z-axis or a line parallel to z-axis. So our location is here. P 1, 3, 2. I hope this makes sense to you all. So next, let's talk about graphing the functions in R3. So the ideas are variables that are not expressed in the equations can take any value without limit. So for example, let's graph the equations y equals to 2 in the first diagram, z equals to 3 in the second diagram, and x square plus y square equals to 4 in third diagram. So let me talk first graphing y equals to 2. Y equals to 2 in 2D is just a horizontal line. At y equals to 2, it can take any x value, so it's a whole horizontal line at y equals to 2 in 2D. Now in 3D, here x and z are missing, so we can take any value of x and z. So first mark y equals to 2. So on this 3 dimensions here, on 3 coordinate systems here. So this is y equals to 2. Then I can take any x and any z. That means I can extend towards plus x and negative x. And I can extend this towards positive z and negative z. That means I am stacking the y equals to 2 lines, bunch of lines, upwards as well as downwards. Then I put there. So that is a flat plane. I hope this visualization makes sense to you all. Similarly, let's move on middle diagram here. So here's middle diagram, z equals to 3. So mark at z equals to 3. That's the height. And then x and y missing, that means x and y can take any value. So that means this can go either side of x-axis and either side of the y-axis. That means just a flat plane. That's a ceiling, right, at z equals to 3 height. So I hope this plane makes sense to you all. Similarly, let's move to the third diagram. Here x square plus y square equals to 4. So now here the z variable is missing. Simply x square plus y square equals to 4 is a equation of circle in xy plane. So it's a circle in xy plane with radius 2, center at origin. Since z variable missing, that means now I can move this circle up and down with taking any positive z value, taking any negative z values. That means I'm stacking the circles up as well as down. Then this forms a cylinder. I hope this makes sense to you all. Now let's move on. Quick remark. The graph of function of single variable is called a curve, and the curve lies in R2. Means the graph of function of single variable lies in one higher dimensions from R1 to R2. The graph of function of two variable is called the surface, and the surface lies in R3. That is, a curve has an equation in x and y, whereas the surface has an equation in x, y, and z. Great. So now let's move on. Next, let's talk about finding the distance in R3. So the key idea here is Pythagorean theorems. We know the Pythagorean theorem in right triangle here. The hypotenuse square equals to base square plus perpendicular square. We can sketch a proof. It's very short and sweet. Let's take a square here whose side is a plus b, a plus b, a plus b, a plus b, and draw another square inside that big square. The inside square side is c, 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 c. Then area of outer square equals to area of inside square plus area of this 4 triangle. So outside square area is simply a plus b outside square equals to area of inside square is c square plus there are 4 triangles, so 4 times area of triangle is half base times the height. Height is a, base is b, so half ab. Simplify, it gives you a square plus b square equals to c square. So let's move on. Then let's talk about finding the distance between 2 points in the space. So pick a point P with coordinate x1, y1, z1 and q, x2, y2, z2 in R3. Then we want to find the distance PQ. So the idea is first project Q in the plane where P lies. So the projection of Q is R, whose coordinate are same x2, same y2 coordinate, but z2 changes to z1 because I am projecting Q onto R, where R lies on the same plane as P. Then we form this right triangle. Then in this right triangle, the distance PQ equals to radical PR square plus RQ square. So PR is square. So PR is square. This is the distance between 2 points in the plane. So x2 minus x1 outside square plus y2 minus y1 outside square, and plus z1 minus z1 0 by the way, and plus RQ. RQ is this distance. This distance is simply z2 minus z1. So z2 minus z1 is square. So that means we added this z component on this distance formula in plane. So the distance formula in R3 is d equals to under the radical x2 minus x1 outside square plus y2 minus y1 outside square plus z2 minus z1 outside square. I hope this makes sense to you all. Quick remark: to show that 3 points in the space lie on a straight line, One way is to show that the sum of the two shortest distances must be equal to the longest distance. Next, equation of sphere. An equation of sphere with center H, K, L and radius R is given by x minus h outside square plus y minus k outside square plus z minus L outside square equals to R square. This is simply we are adding this third terms here on the equation of circle, right? Last remark, if the equation has x square, y square and z square as its highest degree terms, that means second degree here, and they all have the same sign, then the equation represents a sphere. To find its center and radius, one needs to use the completing the square technique. Now with this theory concept, so let's do some examples. So example 1, draw the graph of the equations z equals to 6 minus 3x minus 2y in first octant. By the way, it's a plane, 3x plus 2y plus z equals to 6. So the one way to graph this equation or this plane is using the x-intercept, y-intercept and z-intercepts. That means this plane crosses the x-axis at put y and z 0, that means x equals to 6 divided by 3, 2, so 2, 0, 0 at point P. Similarly, this plane intersects our y-axis at 0, 3, 0 at point Q. Put x and z 0, so y equals to 6 divided by 2 is 3. And similarly, the z-intercept is r 0, 0, 6. This point we got by putting x and y 0, so z equals to 6. Then plot these intercepts point and connect them. So this is x-axis, this is y-axis, this is z-axis. This is the point P, this is the point Q, this is the point R, and we join those points. Now this plane is the graph of this plane or these equations. We can use another idea also. We use a projection idea to find the projections. We project this plane onto the xy plane, put z equals to 0. We project this plane onto xz plane, put y 0. Similarly, we project this plane onto yz plane, put x equals to 0, which are the equations here. But I have not covered the projection yet, so I will postpone that idea until we cover the projection. Let's move on. Example 2, find the distance between 2 points in space. The point is P and Q with the coordinate. P has coordinate -2, 1, -1, and Q has coordinate 1, 0, 4. So let's begin the solutions. Apply the distance formula. So distance PQ equals to, under the radical, so x2 minus x1 square, that means 1 minus 2 outside square, so 1 plus 2 square. Then plus y2 minus y1 square, that means 0 minus 1 outside square, plus z2 minus z1 square, means 4 minus 1 plus 1 outside square. Simplify, it turns out to be radical 35. The radical 35 unit is the distance between these 2 points. I hope this makes sense to you all. Now let's move on. Example 3. Find the distance from the point P to each of the following. Part A, xy plane, that means simply the z coordinate, 6. Part B, yz plane, simply the x coordinate, 4. Similarly, part C, xz plane, the y coordinate, simply 2. Part D, the x-axis, Keep in mind, x-axis and xy plane is different. Okay, so from the x-axis I need to pick a point in x-axis which is closest to point P and apply the distance formula. So the closest point on x-axis to P is, keep the same x coordinate, then y and z are 0 in x-axis, so that's the Q 400, and apply the distance formula and find the distance PQ, which turns out to be 2 times radical 10. And again the formula here is the distance PQ equals to under the radical x2 minus x1 outside is square plus y2 minus y1 outside is square plus z2 minus z1 outside is square. Here x1, y1, z1, and this point is x2, y2, z2. I hope this makes sense to you all. Now let's move on. Example 4. Find the equation of a sphere with center at 1, 2, 3 and radius 4. Begin the solution. Just apply the formula. X minus 1 outside is square plus y minus 2 outside is square plus z minus 3 outside is square equals to radius is square. Simplify. Keep just these equations. X square plus y square plus z square minus 2x minus 4y minus 6z equals to 2. Now let's move on. Let's do example 5. So that x square plus y square plus z square plus 4x minus 6y plus 8z equals to negative 4 represents a sphere, and find its center and radius. So the idea is somehow I need to convert this equation, or I need to rewrite this equation in the standard equation of the sphere, which is x minus h outside is square plus y minus k outside is square plus z minus l outside is square, where h, k, l are centers and r is radius. Then we're done. So then let's use completing this square technique here. So let's collect the x terms. So x square plus 4x, leave this spot blank because the magic number goes there. I'll tell you later. The y terms are here, leave this blank, plus z terms here, leave this blank, and negative 4 as it is. And in this first blank, so to make this perfectly square of some binomial terms, divide the coefficient of x by 2. So 4 divided by 2 is 2 and is square here, and add this number other side also. So we add 4 this side. Similarly, in the second blank spot here, divide the coefficient of y by 2. So minus 6 divided by 2 is minus 3 is square 9. So this goes on this mystery box, plus 9 as well as plus 9. I hope this idea makes sense to you all. Similarly, on this last blank box or mystery box, divide the coefficient of z by 2. So 8 divided by 2 is 4, square is 16. Write 16 here as well as 16 to your right hand side also. And simplify this constant, it gives you 25. And this 3 terms gives you this x plus 2 is square. This 3 terms gives you y minus 3 outside is square. And this 3 terms gives you z plus 4 outside is square equals to 5 square. So comparing this last expression with the standard equation of sphere, our center is minus 2 plus 3 minus 4 and radius is 5. Awesome. I hope this makes sense to you all. Let's move on. Example 6. Determine whether the given points in the space lie on a straight line. Solutions. So let's find the distance PQ, QR and PR, and if sum of the two shortest distance equals to the longest distance, then the answer is yes, these 3 points lie on a straight line. So solutions. So compute the distance as PQ under the radical. So here is a x2 minus x1 square plus y2 minus y1 square plus z2 minus z1 square. That means 1 minus 0 square minus 2 minus minus 5, which is minus 2 plus 5 outside square. 4 minus 5 square. Simplify, it gives you radical 11. 1 plus 9 plus 1. Similarly, find the distance QR. So QR. So under the radical 3 minus 1 outside square. 4 minus minus 2 means 4 plus 2 outside square. 2 minus 4 outside square. Simplify, gives you 2 times radical 11. Finally, the distance PR. So P here, R here. So under the radical 3 minus 0 outside square. 4 minus minus 5, 4 plus 5 outside square. Plus 2 minus 5 outside square. So 3 square 9, 9 square 81, 3 square 9. Simplify, it gives you 3 times radical 11. And since this sum of the first two distance equals to the third distance here, the longest distance, the given 3 points lie on a straight line. Great. So I hope this makes sense to you all. We finish section 12.1, and in the next class we will study the vectors. Thank you.